my favorite planet here, and this has inspired us to go out and look in the universe. Are there other Earths out there? What are the other planets out there like? And this month was a big month.
Goldilocks.
Goldilocks, yes.
Does anybody know what that song is? We didn't know it either. Carolyn actually found it, and we loved it, but none of us had known it before. Who's the artist again?
Beatty Bell.
Beatty Bell.
Beatty Bell, plug for Beatty Bell.
Okay.
Right. So yes, this was a big month for exoplanet news, and we're going to take a look at just some headlines that came up. Hospitable planets, Goldilocks planets, Earth-sized planets around ancient stars. I mean, there's just a ton of stuff came on, and I was like, how are we going to cover all of that? So that gives you the idea it was a big month. So I'm going to try and wrap it in a package. As you can see here, this is the discovery of planets through the years. The first one back in 89, 92, we knew of another 94, and then all of a sudden, boom, it ramps way up there. What was going on there? Well, that was the Kepler Space Telescope, of course. It went out there, stared at a bunch of stars, and it found some planets. Last year, they announced hundreds and hundreds that came through. This year, 2015, a little bit slowed down. It's partially because Kepler has lost one of its reaction wheels. It's having to observe in a different mode. Nonetheless, a lot of exciting stuff has happened. So let's take a quick overview of it. This is the planets that have been found out there. So these are around other stars. We're above 1900 now. So these are confirmed ones. The Kepler ones are in yellow. It's found all of these. This axis going this direction is orbital period. So Earth would be out in here-ish, 100 to 360. And Earth would be located right there. So here are two planets that orbit about the same amount of time around their star, and they're about the size of Earth. However, that doesn't necessarily mean those planets might be habitable. The star might be hotter than our sun. It might be colder than our sun. So we have to worry about those things. We're looking for a planet that has liquid water on the surface so life can live there. So let's take a look at the next one. That's that Kepler telescope I was talking about, and they're using it in a different mode to still find planets. In fact, it's found another solar system, so it's still working well. But the bulk of the planets you saw were found by this, and we can take a look very quickly. Maybe just run half the video, go till it's in the middle. That little black dot is a planet passing in front of its star. It blocks a little bit of the light, and we can measure how much light it's blocking. That tells you how big that planet is, the size of it. It doesn't tell you what the planet's made out of, however. So Kepler was able to see planets that were 19 times bigger than Earth, all the way down to planets that were much smaller than Earth. Jupiter, Neptune, and Earth are marked in their red boxes to show you. So the Kepler telescope is finding a wide range of sizes. But again, this does not tell us whether these things are rocky or gassy or what they're like, or whether they could have liquid water. A little more work has to be done. Go forward to the next slide. The habitable zone that can tell you whether something has liquid water, that's the range where you're not too hot, where the water boils off, you're not too cold, where it's going to freeze. It's just right, hence the Goldilocks zone, right? It's just right. Mama bear, or baby bear. Baby bear. We had that wrong the other day, and now it's stuck in my head that way. Earth is here, so we are in the habitable zone. Mars is right on the edge out in here-ish. Well, I guess we'd want to go this direction. But we want to find planets that are in that green zone. And we have. So let's go forward and take a quick look here. Planetary equilibrium temperature. Well, equilibrium, it might get a little hotter, sometimes a little colder, but it's going to come to some equilibrium. We want ones right in that range. So this is the radius. So things between 1 and about 2, although they've plotted up to 3. Over here, 1 to 2 times the size of the Earth. There's a lot of candidates in there that could be the right temperature. So we're finding things that could be the right size. Let's take a look at the next slide here. So here's our best candidates for potentially habitable exoplanets, and they're ranked in distance from Earth. The nearest is only 12 light years away. That's Tau Ceti E. The furthest one we found so far is, what is that number? Can I read it? 2,541 light years away. And the sizes range. Earth is here. These are mostly larger than Earth. Kepler, although it could see things Earth-sized, it was much easier to see big things, of course. Jupiter blocking out. It blocks more light. So, this is not an even sample, but it's showing these things are out there. There are things that can have liquid water on their surface. But again, we're still not sure they're rocky. So let's go forward one more slide here. This is the best examples from the Kepler one. This is the top 8 that it's found so far. Artist concepts, again, we don't have pictures of the surfaces of these. So when you see a planet with blue water and it's not actually Earth, an artist did that, just so you know. Let's take a look at the next one here. I believe we're getting towards the orbital period and mass. You can measure the masses of these planets if there's multiple planets in the system. As the planet goes around, it affects the other planets that are there. Many of these are in 2, 3, 4, 5 planet systems. So you can measure the timings as these things orbit and calculate the masses of each individual planet. By doing that, then you can get what they're made out of. And let's take a look at the next plot here. Indeed, put these planets on a graph that is radius versus mass. So, and that is in Earth masses, so Earth would be way over here at 1. But water planets will fall along this line. Water worlds, where's our Kevin Costner picture? I needed one this time.
I can't believe it.
Our iron planets, a planet of pure iron would be somewhere in here. So these are rocky. These things have densities that are the same of rocky planets. We've proven they're rocky. That's something they've done. And that was that headline of the ingredients that go into making a rocky planet like Earth. We're seeing them out there. We're seeing things with the same densities as Earth. So that's important. They're not just big and gassy, although they can start that way. They can start out as Neptune, and they've calculated those solar winds, like Titan being left out from the magnetic field. They can blow away enough of a planet like Neptune, enough of the atmosphere to leave something rocky behind. So maybe some potentially habitable planets could have started as Neptune, and it even made me wonder, could Venus have started that way? I don't know. Maybe that's why it's so drastically different. If we look at our next one here, we can take a look at a beautiful ocean with a giant planet in the background, perhaps. Maybe we're a moon going around that one. Well, they found a few things about water around exoplanets. One of which was super-Earths, planets that are really big, things 2, 3 times the size of the Earth, 2, 3 times the mass of the Earth. They actually are better at holding on to their oceans. They have so much mass, their oceans stick around a really long time. That's good news for trying to form life, because you have that liquid water, it's moving around all those chemicals, it's in contact with the rocky surface, so that chemistry can get going perhaps. So that might be a good sign for life forming around these super-Earths. Another one that was found is that small planets, if we go forward to the next slide, we can take a quick look here, little planets around red dwarf stars. So a star that's very small and much cooler than the sun, you have to orbit closer to it to keep your water liquid. If you're too far from it, it would freeze. But if you're close enough to it, your planet locks. The same side of your planet will want to face the star all the time. Our moon does that. If you notice, you always see the same side of the moon. Well, some people did some calculations, astronomers and physicists, and they said, well, if there's an atmosphere on there, it can keep the thing spinning differently than its year. So the water won't freeze out. Again, all of a sudden, a ton of more places to have life. And if we take a look at the next slide, we can see why that is. These little faint red stars, there's tons more of them. Factors of tens more than there are other kinds of stars. So again, the potential place for life to form around these exoplanets just went up by a giant factor. And I think we just have a couple of more little exoplanet news things here. They found rocky planets around a star that is 11 billion years old, 11.2 billion years old. Why is that important? Well, the supernova, the exploding stars that make the stuff that the rocky planets were out of, we weren't sure if enough of that stuff was around to make rocky planets or how far into the past you could do it. Well, we found a star that's 11 billion years old that has rocky planets. Our sun is only 4 billion years old, so that alien civilization has had quite a head start if they formed on that planet. It could, who knows? But this just means, again, the chances and places that life might have gotten started, could have, places that could have liquid water has increased. And then let's just go through the next ones really fast. They measure the ages by stars by looking at the star spots on them. They can see as they rotate, and the star slows down.
Artist conceptions. Artist
conceptions, exactly. So this is a big star spot. You go to the next one, you can see later in its life it's going to have smaller star spots that rotate slower, so they can actually do that. And then there was the giant ring that was found. Oh, well, this was just showing in the timeline of the universe. Now we can have planets back in here somewhere rather than up in their rocky planets. We knew that gassy ones could be made, perhaps, but we weren't sure about rocky. And then lastly, in the exoplanet news, the giant ring. This is phenomenally cool. I'm not so sure it's right, but it's phenomenally cool. They saw eclipses. Remember when I showed the planet going in front of its star, it blocks out a little of the light? Well, you can get a light curve. You can measure it. And let's take a look at the movie here. So they're measuring the brightness of the star, and then all of a sudden it starts to dip. It gets dimmer. And the dots are the actual data. They're filling in elsewhere from lines on the other side, but this looks a lot like when a star would go through the rings of Saturn. So starlight passing through the rings of Saturn, it gets brighter, gets dimmer as the rings block it. That's what they saw around this star way out there. But these are well outside the size of Saturn's rings. This isn't tidal forces stripping things. I think this is probably like a moon-forming disk around a giant planet. That this thing had something happen, and there are rings there and probably objects forming in those rings. So amazing result to think we might have seen a ring system around an exoplanet. Quick question?
Do you think there's any hope of doing like a Hubble-type rescue for Kepler and fixing that?
No, they won't be able to do any Hubble rescue for Kepler. The observing mode it's in now, they're getting a bit more data out of it, but there are some more satellites coming up. I think TESS is a mission. I think it's been approved and will go forward. Anyway, there are several other missions that will do more and better. And Kepler, it lived about the length of life they thought it would. So a fantastically successful mission.
It's too far away to reach.
Yeah.
Whereas Hubble is in low Earth orbit, so that's why we've been able to go there with astronauts and fix it.
Oh, and then NASA put out some fun posters. You can download these if you like. They're based on some of those, well, what we think the exoplanets might be like. You know, where the grass is always redder on the other side, although that doesn't make any sense if you know the science. The middle one experienced the gravity of a super Earth. I mentioned parachuting down onto a super Earth. My favorite is the one on the right-hand side, Kepler 16b. That's like a Tatooine planet. There's multiple stars, where your shadow always has company. So.
And just because there were travel posters, and you guys saw an earlier travel poster that I showed you, I thought I'd show you the others. Yes, we do have a cat theme tonight. These were actually tweeted last week by Emily Lakdawala, who was a guest here a couple of months ago, so I just thought I'd share it.